Let's look at some polynomial approximations of elementary functions. Now we've already done a first order approximation. A first order approximation is a tangent line. Now we needed the following two conditions. The function at the point we're expanding about has to equal the polynomial at that point. So both graphs have to pass the same point, and they have to have the same slope at that point. Now, a first order polynomial, P1 of x, is going to be a0 plus a1x. So P1 prime of x is just a1. What if instead I wanted a second order? P2 of x is going to be a0 plus a1x plus a2x squared. All right, what if I wanted a third order polynomial? You should see where this is going. So this is a0 plus a1x plus a2x squared plus a3x cubed. And in each of these cases, we're going to need the function to pass through the point, the slope to be the same, and you can see as we go higher up, we're going to need the second derivatives to be the same and the third derivatives to be the same. Now, suppose we want a first degree polynomial approximation, so this is a tangent line of f of x is e to the x. And so I know my polynomial approximation is a0 plus a1x, and we're going to look at x equals 0. Before we get started, let's just find everything. F of x is e to the x, f prime of x is e to the x. Now let me find the functional value at these points. F of 0 is e to the 0, which is 1. F prime of 0 is e to the 0, or 1. Now let me look at my polynomial functions. P1 of x is a0 plus a1x. P1 prime of x is just a1. Now, what is P1 of 0? P1 of 0 is just a0, and P1 prime of 0 is a1. So I'm looking for a function so that these agree at the point x equals 0. So what do I need? I need f of 0 to equal P1 of 0. So I have 1 is equal to a0. I also need the first derivative to equal P1 prime at 0. So I have 1 is a1. Well, this was pretty straightforward. P1 of x then is a0, which is 1, plus 1x. So let me rewrite this as P1 of x is x plus 1. This is a first order linear approximation of the tangent line e to the x at the point x equals 0. Now you can see this is going to be pretty close until you get very far away. And then we're going to need higher order approximations. Now, if we were to construct a table comparing the values, then of e to the x and the third order approximation, I can see that they're very close when I'm very close, but then they do start differing quite a bit. Now for this, you need a calculator or a computer. These aren't calculations you're going to do by hand. Now suppose I wanted a second order approximation of e to the x. All right, so I know f of x is e to the x, f prime of x is e to the x, f double prime of x is e to the x. Because we're doing second order, we're going to need everything up through the second derivative to be equal. So f of 0 is 1, f prime of 0 is 1, and f double prime of 0 is 1. Now what does my polynomial approximation look like? Well, the second order approximation is going to be a0 plus a1x plus a2x squared. So let me go on and find, let's do it this way. P2 prime of x is going to be a1 plus 2 a2x, and P2 double prime of x is 2a2. So now let me find P2 of 0, because that's the point we're looking about, and that's just going to be a0. P2 prime at 0 is simply a1, and P2 double prime at 0 is 2a2. So now I'm going to come down here. I need them to agree at the point, so I need f of 0 to equal P2 of 0. And this tells me that a0 is 1. I need f prime of 0 to equal P2 prime at 0. And this tells me that a1 is also equal to 1. Now, for the second order approximation, I need the second derivative to equal P2 double prime at 0, which tells me that 1 is equal to 2a2, or that a2 is 1/2. So a second order polynomial approximation for e to the x is going to be 1 plus x plus 1/2 x squared.